What is the pH for a solution at 25 degrees Celsius that has an OH concentration of 8.2 times 10 to the negative fourth? Right, turns out we have a couple ways we can do this. We either need to take that OH concentration and first turn it into a H3O, and then from there we can get a pH, or we could have actually decided to turn that into a POH first and then turn that into a pH. And I'm going to do both. Alright, so if I wanted to go that top route, I'm going to rely on the fact that OH minus and H3O plus always equal the KW, which is 1.0 times 10 to the negative 14th. Therefore, if an OH is 8.2 times 10 to the negative 6th, its H3O concentration can be found by taking just the 1 times 10 to the negative 14th and dividing that by 8.2 times 10 to the negative 6th. And we get an H3O concentration of 1.2 times 10 to the negative 9th. And then to turn an H3O into a pH, we just have that pH equals the negative log of H3O. So I just need to take the log of that value and then flip the sign when I write this down. So it gives me a pH of 8. I need two significant figures, so 2 decimals on a pH. That should be my answer. Now, if I did it this other route, what I would have done instead of, at first, I would have taken that OH concentration and taking the negative log of it and determine the POH. And if I do that, log of 8.2 times 10 to the negative 6th, I get a POH of 5.09. And where this gets to be a heck of a lot easier, it turns out pH plus POH always equal 14. So 14 minus 5.09 gives me that same 8.91.